We've been doing all this graphic stuff, which makes some people nuts, either because it's not exact enough or because, like, I just don't understand it and I'm not a visual person. Okay, whatever. We're going to do, these are fantastic as a quick check, especially on things that are, well, that was the worst line I've ever drawn, on things that are not perpendicular to one another. Still terrible, Moser. So if I do that path of travel, and let me not be a hypocrite when I yelled at somebody about where are the arrows on your vectors, you know, if I want to do that algebraically, I can, but it's a pain. Much easier to do that one graphically and get a rough estimate. Well, what about ones that are easy to do algebraically and trigonometrically? What if I do something really simple, like go 10 meters east and 5 meters north? Do I need to solve this graphically? No! Gotta love the Greeks. What am I going to use here? Pythagorean theorem. You people have been doing this since you were in, like, what, 3rd grade? Something like that. So a squared plus b squared equals c squared, where your hypotenuse is, of course, your, you know, d resultant or whatever you want to call it. So what's the resultant here? Okay, so we know that it is 10 squared plus 5 squared equals, oops, the resultant squared. Well, actually, you know what? Hold on, Moser. Jeez Louise. We've got Pythagoras there. I'm going to be a complete pain in your butt. Of course. That's what I live for. And I'm going to say here that 10 meters east is what displacement? X or Y? X. So this is delta X. That 5 meters is delta Y. So I'm going to rewrite this. Delta X squared plus delta Y squared equals resultant squared. Therefore, square root of delta X squared plus delta Y squared equals my resultant. Yes, I'm actually going to write that out. I'm not going to use A, B, and C because this is physics and we're doing work in the real world. So on a test, believe it or not, as stupid as it sounds, I give you a point for writing delta x squared plus delta y squared equals r squared. And then well, sometimes even if I'm feeling really generous and I've had enough coffee when I'm grading, give you another point for writing square root of delta x squared plus delta y squared equals r. And then a point for plugging the darn thing in. Jeez, it's like a points free-for-all. So square root of 10 squared plus 5 squared equals r. Yes, as young Garza so aptly pointed out, square root of 125 equals r. What is that? 11 point. Oh, that's good. That's a good skill. That's good mental math. If you can actually start to figure out approximations of square roots in your head, that's excellent exercise. It'll probably save you from dementia later in life. No kidding. I see your gum. Spit it out. Okay, so we've got, 11.18, blah, blah, blah. We actually only have one sig fig because somebody did a terrible job writing this problem. Let's give ourselves at least 2 sig figs. I'll fix that. Point 0, and then we'll come up here. Here, we'll give ourselves 3 sig figs. 0.00. Okay, so that gives us a resultant of, yes, 11.2, correct, young McCoy. Okay. Now, are we done? No, of course we're not done. We're not done because we don't know 11.2 meters in what direction. What do we have to do? We have to use trig! Yay! Trig! I love trig. Tangent. Let's do a quick trig. Yes, we just did that. We know that Pythagoras gives us the magnitude of the resultant. And then to find the direction of the resultant, you got it. We got to use trigonometry. So katoa is a very helpful thing. You guys all are smart, clever critters, and you correctly identified that to do resultants, we're going to use tangent. And it's pretty easy. So, because I'm such a pain in your tuchus, no, it's because I'm making sure you have good bookkeeping on this kind of stuff. It actually develops a discipline of mind that's useful in everything else. What is going on here? Okay. Whoa. Okay. I'm going to write this. Tan theta equals, well, what's my angle? What angle am I measuring? That. So what's my opposite? I literally do this because my little pea brain can't keep track of things neatly. So tan theta equals delta y over delta x, opposite over adjacent. If you need to write TOA on your paper, you are more than welcome to. So then I'm going to write inverse tan negative 1 of delta y over delta x equals theta. Now I'm ready to plug in numbers. Again, I'll give you points for that. You do it, I give you points. It's like bribery. So inverse tan of 5.0 meters over 5.00 over 10.0 meters equals theta. What's theta? Degrees equals theta with 3 sig figs, 26.6 degrees equals theta. Are we done? Perhaps you've all caught on that when I say, are we done, that's a short way of saying no. What else do we need to do? Oh. Whoops, okay. So I can't just say I need a direction. If I put a compass rose there, I know that this is north of east, so this is 26.6 north of east. Yes, sir?
I thought we weren't...
There were no cardinal directions on this problem. You know, what if I just said you walked 10 meters right and then 5 meters forward?
Right.
You know, then you have to figure out a heading that fits that circumstance. So, not up of down. But you could say forward from the right. Sometimes the ones in your book will do crazy things like, you know, at 26.6 degrees counterclockwise of the positive axis. Yeah, that's crazy stuff. But yeah, you have to assign a direction to it. Okay, so now, oh, well, there we are. So yeah, we usually call our angle theta here. I think they do the same thing in math. So this is 3A, and they're all assigned. So page 91, 1 through 4. I'll give you the rest of the time to work. Not all of these even require trig or algebra. Some of them are just stuff that's the simple straight line vectors. Do you want to do the 3A sample problem together? We can. Okay, we'll do that. This is 3A sample. The pyramid is 136 meters high. It is 2.30 times 10 to the second meters wide. If they climb from here to here, what is their displacement? So again, we have a triangle that's created for us. Their x displacement, so delta x equals 0.5 times 2.3 times 10 to the second meters, because of course they're only going half of the width. And delta y equals 136 meters. We know that delta x squared plus delta y squared gives us our resultant squared. So the square root of delta x squared plus delta y squared gives us our resultant. 115? Yeah. So square root of 115 meters squared plus 136 meters squared gives us our resultant. What is it? Okay. Okay, so 178 at 49.8 degrees above the horizon. Oh, look at that, a real calculator. calculator. Who knew? So do it, love it, learn it. I'm not going to give you the worksheet on these because I think these are fairly simple. I don't think you need the extra practice. When we get to the non-perpendiculars, I'll give you some worksheet stuff.
Because there's been a ton of problems in math where I'm like, I mean, I could make this a right angle, but I don't know how to do it.
That's excellent. We're going to do that later.
Okay.
We're going to create right angles out of non-right
I know how to do them out
angles.
of like isosceles.
All right, so do the homework, practice.